Sanbonani Abafundi, welcome back. We're continuing with our study of prime numbers, and we're going to just kick off first up by just reminding ourselves that we had these two ways of prime factoring a number. I actually prefer the tree, and I think you'll see why now, but let's use the ladder first. So what we're going to do is we're going to look at the smallest prime number that divides into there. Now remember, the smallest prime number is 2. It's definitely going to divide into there because this is an even number. And we get 6050. Right. Now 2 will divide into that again because it's an even number. So, and we get 3025. Right. Now 2 doesn't divide into here. We could test whether 3 divides in. Remember, if these digits add up to a multiple of 3, 3, 5, 10, no, they don't. So 3 doesn't, but 5 definitely does because it ends in 5. Right. Now we're going to divide 50 into here. 50 goes into 3,600 times and into 25 5 times. Right, now 5 will divide in again, and it in fact divides in 121 times. Right, now 5 doesn't divide in there, nor does 7. The next prime number after 7 is 11. Yeah, if we know our times tables, we'll know that 11 divides into 121 11 times, and obviously 11 divides into itself once. So the prime factorization of 12,100 is just 12,100 can be written as 2 2's multiplied together, 2 5's multiplied together, and 2 11's multiplied together. Now remember, 2 2's multiplied together, 2 squared, 5 squared, 11 squared. I'm going to show you how to do this one using the tree diagram. And for me, it's fairly obvious that we could multiply 121 by 100. Okay, now to get 12,100. Okay, now this is not prime, and again, if we know our times tables, then we'll know that that's 11, which is prime, times 11, which is prime. Okay, 100 is not prime. 100 is actually 10 times 10. 10 is not prime. 10 is 2 times 5. Now, as you work with these numbers, you'll get better and better at this, okay? And obviously this 10 is also 2 times 5. Remember, I'm putting them in circles when they are prime numbers. Now, all these numbers that are in circles, sorry, these 10s should not be in circles. Okay, so let's fix that. Those 10s should not be in circles. They're not prime numbers, so we carry on. When we're done, all the numbers inside circles are our prime factors. So 12100 can be written as 11 times 11 times 2 times 5 times 2 times 5. Now what we tend to do is we tend to group the smaller bases first, and then we collect them together. So 2 2's, 2 5's, and 2 11's, and there's the prime factorization. Notice it's exactly the same as we got with the ladder method. I prefer the tree method. I think it's quicker. Right, now you can practice this skill. You can practice it while you're driving home. You can practice it while you're walking along. The new number plates in KZN now are the same format as these Joburg ones, but 10, 2 times 5. 30, let's see if we can do that in our head. 30 is actually 5 times 6. All right, now 5 times 6, that's all right, but 6 is not prime. What is 6? 6 is 2 times 3. So in fact 30 is 2 times 3 times 5. We're going to pause the video and we're going to ask you to try using any method you like to see if you can prime factorize these number plates. So actually none of them are too bad. Remember that if they've got zeros on the end, zeros are either 10s, which is a 2 times a 5, or hundreds, which is 2 2's times 2 5's, or thousands, which is 3 2's times 2 5's. Okay, pause the video, have a go, see how you go, then let it play again and we'll go over them. Okay, let's take a look at 20. Well, 20 is just 5 times 4. But 4 is not a prime number. 4 is 2 times 2. So the prime factorization of 20 is actually 2 squared times 5. Okay, right. Let's do 8,000. Now you might think, oh, 8,000, that's terrifying, it's huge. But in fact, it's just 8 times 1,000. All right, now, if we think about 1,000, 1,000 is 10 times 10 times 10. But what is 10? 10 is 2 times 5, right? But we need 3 lots of 1,000. So in fact, 2 cubed times 5 cubed. Okay? That's 1,000. You can check it for yourself because 2 times 5 is obviously 10. And if you cube that, if you multiply it by itself, you're going to get 3 lots of 2, 3 lots of 5. You're going to get 1,000. Okay, what about 8? Well, 8, and hopefully you might soon get to realize this, 8 is actually 2 times 4, but 4 is not prime, 4 is 2 squared. 8 is actually 3 2's multiplied together. All right, now let's take a look at this. This is in fact, how many 2's have we got multiplying here? We've got 3. And how many here? We've got 3. How many have we got altogether? We've got 6. We can write this as 2 to the 6 times 5 cubed. And that's the prime factorization of 8,000. Okay, I don't want to show off, but I could do that in my head. And you guys can do it in your head as well with a little bit of practice. Okay, I do want to show you how you can check that answer on your calculator, although we're not encouraging you to use calculators at this stage. Okay, so if we type in 8,000, we press equals and we go shift fact. Not all calculators have this button, but there you'll see it. 8,000 expressed as a product of prime factors is 2 to the 6 times 5 to the 3. Okay, let's look at how you got on with these other ones. 300, I don't think 300 is too bad at all. 300 is just going to be 3 times 100. Now remember, 100 is 10 times 10. All right, but we already know what 10 times 10 is. We already know that a 10 is a 2 times a 5. And another 10 is another 2 times a 5. Okay, and the way we like to group them is we like to group them from the smallest to the biggest. 2 2's. 2 squared means 2 times 2. Only 1 3, Ellie Lordwa. And then 2 5's. And that is the prime factorization of 300. 980, now you might, wow, 980. Okay, but 980, let's just think about that. 980 is 98 times 10. 98 is an even number, all right? It's nearly 100. Half of 100 would be 50. Half of 98 is actually 49. So this is actually 2 times 49. Do we know what 49 is in terms of prime numbers? We should, because we should know that 49 is the same as 7 times 7. And 10 we're doing often. We look at the 10s that keep coming up. 10 we know is 2 times 5. Final answer for 980. How many 2's? 2. How many 5's? 1. How many 7's? 2. Right, that's the prime factorization of that. Okay, 1750. Let's think about that. Well, obviously we've got 175 times 10. We know what 10 is. We know that 10 is 2 times 5. It's like an old friend. Okay, 175. That is definitely a multiple of 5. Now 5 goes into 175. All right, it actually goes in 35 times. So 175 is 5 times 35. What about 35? Well, 35 is 5 times 7. So in fact, this number 1750 is actually 1 2 multiplied by 3 lots of 5, not 3 lots of 5, multiplied by 5 times 5 times 5, 3 5's multiplying together, times 7. And again, just because we can, let's check that on our calculator. All right? 1750, shift fact, and there it is. It's a 2, it's 3 5's, and a 7, all multiplying together. Now this is this is a really important idea in terms of being able to prime factorize things. Okay, I don't expect you to necessarily do it that quickly to start off with. This number over here, okay, and I want us to write down some numbers here because these are the numbers which we call the powers of 2, okay? 1, 2, that's a 2, that's 2 2's multiplied together, that's 3 2's. Notice I'm just doubling. That's 16, that's 32, that's 64, that's 128. All of these are just a whole lot of 2's multiplying together. This is 1 2, that's 2 2's, 3 2's, 4 2's, 5 2's, 6 2's, 7 2's. If you know your powers of 2, then you'll know that that piece there is actually just 7 2's multiplying together. Right? 128 is 7 2's multiplying together. Then we've still got the other 100. So we've got 7 2's times 100. But remember, we know about 100. We know that 100 is 2 times 5 times another 2 times 5. It's just 10 times 10, isn't it? Right? So how many 2's have we got altogether? 8, 9 2's and 2 5's. Okay, now you can practice, sorry, 2 5's, not 5 5's. You can practice this as you drive down the street. You can even just make up a number. You can bounce the number off your friend. 24, I'll tell you, is 2 cubed times 3. 24 is 8 times 3, but 8's not prime. All right, 56 is 8 times 7. 7's prime, 8's not. 8 is 2 cubed. 56 is 2 cubed times 7. All right, practice, practice, practice. Zama, zama, bese, ungobe. Okay. Right, let's have a look now, and we're going to turn over and we're going to ask you to pause the video and try these ones. You can use any method you like, okay? We'll check your final answers. Rather don't use a calculator. See if you can do them without a calculator. Okay, 36. Well, 36 is 4 times 9. And again, if we know our times tables, then that becomes a whole lot easier. 4 is not prime, it's 2 times 2, and 9 is not prime, it's 3 times 2. Okay, 100, I'm hoping you're good at 100 by now. 100 is just 10 times 10, all right? But each of those 10s is 2 times 5. So what we've actually got is 2 times 5 times another 2 times 5. And so we've actually got 2 squared times 5 squared. I'm going to remind you of how the ladder works. The ladder's not as quick, to be honest. Our brains, particularly if we know our times tables, our brains can break 100 up into things more quickly. But the ladder, remember, we start with the smallest prime number, which is 2. It goes into 100. How many times? It goes in 50 times. Then the next 50 is also even, so it's also divisible by 2, and we get 25. Now, 25 is not divisible by 2. It's not an even number. Then we would check the next smallest prime number, which is 3. Doesn't work. Then we check the next smallest prime number, which is 5. It works. 5 goes into 25 5 times, and the prime number that goes into 5 is 5 as well, and we get a 1 here, and there's our prime factors. 2 lots of 2 times 2 lots of 5. Okay, let's do 350. All right, in my head, and I'm going to do this in my head, 35 times 10. 35 is 5 times 7. And 10 is 2 times 5. So I'm seeing 1, 2, I'm seeing 2 5s, and I'm seeing a 7. That's the answer. All right? Now, it doesn't matter if you can't do it as quickly as I can. But with practice, you'll be able to do it. All right, I'll just do it slowly. 35 times 10. 10 is 5 times 7. Sorry, 35 is 5 times 7. 10 is 2 times 5. Now let's collect all the numbers that we've got here. We've got 1 2, 2 5s, and a 7. All right, 510. Okay, again, I think the easiest way of doing this is to split the 10 out first. This is going to be 51 times 10. Okay, now 51 times 10. Now what goes into 51? Well, 2 doesn't, but 3 does. All right, and with a little bit of kind of practice, one gets better at this, but 3 goes into 5 once, with a remainder 2, and 3 goes into 21 7 times. So this is actually 3 times 17. Now, what do we know about 17? Yeah, it's prime. Okay, and so here's our final answer, because remember 10 is 2 times 5. Our final answer is 2 times 3 times 5 times 17. That's the breakdown, the prime factorization of 510. The next one, 162. All right, 162 is not too bad because we can break it, so 16,200, we can break it into 162 times 100. The 100 is easy because we know about 100. 100 is actually 4 times 25. All right, but I've prime factorized the 4 and I've prime factorized the 25. 100 is just 2 2's and 2 5's. Okay, 162 is even, so it's 2 times something, and in fact half of 160 is 80 and half of 2 is 1. Right, again, as you work more with numbers, you'll become more and more comfortable with this. But what is 81? Well, I'm hoping you know that 81 is 9 times 9. Now, 9 is not a prime number, so we're not quite done yet. But what is 9 if we prime factorize it? What two prime numbers multiply together to give us 9? And the answer is 3. This 9 is 3 times 3. This 9 is also 3 times 3. So what we've actually got here, we've got 2 times 2 3's times another 2 3's times another 2 2's times a 5 squared, which is 2 5's. Now we're going to kind of collect all these things together. If we could write this out in a different order, we could write 2 times 2 squared, and we could unpack the 2 squared to 2 times 2. How many 2's are multiplying all together here? There's 1 over here and another 2 over here. There are 3. How many 3's are there? Well, there's 2 here and another 2 here. There are 4. And how many 5's are there? There are 2. Okay, and that's the prime factorization of 16,200. Okay, we're going to stop there. Just before we do, we're going to check that answer on a calculator. Okay, 16,200 equals shift fact, and there it is. Okay, there it isn't. I thought I had it wrong, but I didn't have it wrong. I typed it in wrongly. Okay, let's fix that. 16,200. And now we go equals shift fact, and we get 2 multiplied by itself 3 times, 3 2's, 4 3's, and 2 5's. Okay, all right, we're going to stop there. Please practice this. Just practice it. Practice it with small numbers. 15, 5 times 3, 14, 2 times 7, 9, 3 times 3. All right, we'll see you next time. Looking forward to it. Have a great day.